evening, students. Today I am taking the topic from class 11th, which is based on straight line. Now, straight line is, I must say, it's a simplest geometric figure. And in this, to study this, how to represent it algebraically, we need to have the knowledge of slope, which is very essential before once you draw the straight line or learn the property of the straight line. Now, here before I start with the slope, I must say we need to know about the inclination of the angle that a line makes with the axis. Now here, a line in a coordinate plane forms two angles with the x-axis. Here you can see this is which are supplementary in the nature. So these are the two angles formed by a line with the axis. Now the angle theta made by the line with the positive axis, with the positive direction of x-axis measured anti-clockwise, that is called the inclination of the line. Here you can see this is a line L, and when we measure this angle between the positive direction of x-axis with the line taken anti-clockwise, this is called angle of inclination. And angle of inclination, this lies between 0 to 180. Okay. One important thing is, like, if the lines which are parallel to x-axis, then what is going to be the angle of inclination? You can very much see if we have this coordinate plane. This is a coordinate plane. Here O is the origin, this is x, y. The line which is parallel to x-axis, they will have inclination of 0 degree. Lines parallel to x-axis will have inclination of 0 degree. But the line which are perpendicular to x-axis, that is, we are talking of the vertical line, they will have the inclination of 90 degree. So lines, or I must say vertical line, will have inclination of 90 degree. Now, since we have understood the angle of inclination, we can continue with the slope. Now, if theta is the inclination of a line, then tangent of theta, this will be called slope of a line. So the slope of a line is here, the slope of a line. At times, slope is also defined as the gradient. This is equal to tangent of theta. Now, if you can see, if slope, like if inclination is 90 degree, then slope of that line is not defined. Slope of a line is not defined if theta is 90 degree. So here, what is the notation that we use to denote slope? This is m. M is equal to tangent of theta, where theta is not equal to 90 degree. And one important thing, since we have mentioned when theta is 90, the slope is not defined. So when theta is 0, how the slope of a line will behave? It will be m is equal to tan 0, it will be 0 degree. Okay, so this is what we need to learn about the inclination of a line, and then in continuation with that, the slope of a line. Now next is, how do we find the slope of a line when coordinates of any 2 points on the line are given? So as you all know, a line can be formed by joining 2 points. So if we have 2 points, a line is formed. How do we find the slope of a line when we have been given the coordinates of 2 points on a line? So for that, what we will do, we'll assume here we have this line. You all can see we have the line L, and its coordinates are P and Q. sorry, the points are P and Q, the coordinates are x1, y1 and x2, y2. So what do? Here we take 2 points and then we drop a perpendicular here from Q to x-axis, that is QR is perpendicular, and again we drop a perpendicular from point P to this axis. Now what do? We assume that the angle of inclination of the line is, sorry, we assume that the angle of inclination of the line along with the this x-axis, positive direction of x-axis, is theta. Now since we have dropped the perpendicular, now these two lines are parallel, so this will also be theta. Now how do we find how this slope is found when when the angle is acute? Like here we'll take the coordinates of this P, the coordinates are x1 comma y1, and for Q the coordinates are x2 comma y2. So here first case is when theta is acute. As you all know, here theta is angle MPQ, this is theta, and this is what the slope of line L, which is M, and this is called tangent of theta. If you recall the definition of tangent which we studied in class 10th, tan theta is perpendicular upon base, that is MQ upon MP. Now MQ, now how will you find MQ? If you see the total distance from here to here, this is y2. This much distance is y1. So this will be y2 minus y1. So this is y2 minus y1. Similarly, this total distance is here. You can see the x coordinate. This is x2. And the distance till here, this is x1. So this result, the distance of MP as x2 minus x1, and hence the coordinates is this distance MP, this becomes x2 minus x1. So here you can see from this equation, we find the slope of a line is y2 minus y1 upon x2 minus x1. So this was the case when angle theta is acute. Now second case we'll take when theta is obtuse. So in this case, how the line is, how will we find the slope when theta is obtuse? So in this case you can see this line L, this is making an angle of this angle, this is obtuse. Okay, so here the coordinates are the 2 points. The coordinates are, we are taking x1 y1, coordinates of Q is x2 y2. Same way we drop the perpendicular from point Q to the x-axis, and we drop a perpendicular from point P to QR, which results that these two are 90 degree, and hence this is parallel. So if it is 180 minus theta, this will also be 180 minus theta. So here angle MPQ, this is angle MPQ, this is 180 minus theta. So, or we can say that theta is equal to 180 minus angle MPQ. So this theta is the angle of inclination of this line with the positive direction of x-axis taken anti-clockwise. We have to find the slope, which is tan theta, that is tangent of 180 minus angle MPQ, which is minus tan MPQ. Now if you take this triangle MPQ, so this is going to be minus MQ upon MP. Now what is MQ? How much is MQ? This total is y2 minus y1. So this is y2 minus y1. Negative sign will remain as it is. And MP, this is x1. This is x1, means from O to Q, OQ is x1 and OR is x2. OR is x2. So we have to find MP. So if I drop a perpendicular, that is this distance, so RL will be here, not OQ, I will take it to OL. Sorry, this point is OL. So RL will be x1 minus x2. So if I put the value here, this is x1 minus x2, negative sign, I'll shift down. This will be y2 minus y1 upon, sorry, this is x2 minus x1. Here OR is x2 and yeah, I made a mistake. This is x1 minus x2 because this total is here x1 and the difference, this is x2, x coordinate. So the difference is x1 minus x2. If we bring the sign inside, this is x2 minus x1. So you can see whether the line forms the obtuse angle or it forms an acute angle. The slope behaves in a similar way. So the slope in both the cases is y2 minus y1 upon x2 minus x1. So slope of a line is irrespective of the angle it makes with the positive direction of x-axis. Now I hope you must have understood what is a slope and how do we find the slope when 2 points are given. So in this case you can easily make out that the slope is irrespective of the angle that line makes with the x-axis. Now next topic that I am going to take is when two lines are parallel and then when they are perpendicular, how do the slope behave? So first case I'm taking if the line L1 is parallel to line L2. So you can see if the lines are parallel, it means they are making equal angle with the positive direction of x-axis. So alpha is equal to beta, and hence if the angles are same, their tangents will also be same. If tangent is same, then m1 will be equal to m2, and therefore the slopes are equal. Okay, if we take conversely, that is if slopes are equal, that is m1 equal to m2, then tan alpha is equal to tan beta. Okay, and here between 0 and we are taking the angle between tangent function between 0 degree and 180 degree. If tangent alpha is tan beta, this implies alpha is equal to beta. So this shows lines are parallel. So vice versa. So what result do we get when the lines are parallel? Then their slopes are equal, and similarly if the slopes are equal, then the lines are parallel. So this is one of the cases when the lines are parallel. How do the slope behave when the lines are perpendicular? So let's take the other case here. If the lines L1 and L2, they are perpendicular, here you can see we have two lines L1 and L2. The angle between these two lines is 90 degree. L1 is making an angle of inclination with the x-axis here. This is y. It's making an angle of alpha with x-axis, and here this is making an angle of beta with x-axis. So you can see by extruder angle property here, beta is equal to alpha plus 90 degree. So tan beta will be equal to tangent alpha plus 90, then that is minus cot alpha. This is equal to minus 1 tan alpha. Now tan beta here, this is belonging to line L2 and tan alpha is belonging to line L1. So we'll take that for L1 the slope of the line is m1, and for L2 the slope of the line is m2. So if it is m1, so this is means this is tan alpha and this is tan beta. So for tan beta we'll write m2 minus 1 upon m1. Sorry viewers, this is m1 m2 is is equal to -1. So it means if the lines are perpendicular, product of their slope is equal to -1. Or here this says tan alpha, tan beta is equal to -1. That is. Now conversely, here we are getting the product of the slope is -1. So conversely, if we take m1 m2 is equal to -1, we'll continue with the same result. And if we shift it to the other side, this is tan alpha is equal to minus cot beta, and it is tan beta plus 90 degree. Okay, or we can write it is here tan beta minus 90 degrees. So in this case you can see alpha and beta, the difference of the angle is they differ by an angle of 90 degree. So it means two non-vertical lines, they are perpendicular to each other if and only if product of their slope is, you can say, -1, or their slope are negative reciprocal of each other. So well students, today we have discussed about the inclination of a line, slope of a line which is tan theta. How do we find the slope of a line when 2 points are given? We'll just recapitulate. That is m2 minus here, m is equal to tangent of theta, and when you have acute angle, this is y2 minus, slope is y2 minus y1 upon x2 minus x1. So is in the case of obtuse angle. And the third thing which I took is when the lines are parallel, slope is equal, m1 equal to m2, and when they are perpendicular, m1 into m2 is equal to -1. So that's it for today. In my next video, I'll be taking questions based on the derivations of the line, whenever how to find the slope of a line when the line is passing through 2 points, and when it is making an inclination of some angle with the positive direction of x-axis. Thank you and have a good day.